and it states that it's asking us which equation can be used to find the measure of angle BAC. So let me just take out my tablet real quick. Which equation can be used to find the measure of angle BAC? So let me write this down. Which equation can be used to find the measure of angle, this is BAC, and we're given this triangle here, right? We're given this, so let me draw this out for you, and we have 4 choices, so let me just draw it out real quick. So this is our triangle here. It's and I'm assuming this is a right triangle, but I don't think they have this here, but I'm pretty sure it's a right triangle here. So right triangle here. So they have 5. This is a 12 and a 13, and they're asking which equation here. So they give us four kind of equations here, and they're asking us which measure to find the angle BAC. So BAC would be here, x here. So which trigonometric ratio do we have to use? So take a moment to think about this problem here. If you're in the chat, again, wave hi and maybe give me the solution to this answer here. What do you think the solution is? And we'll take it up in about a minute or so. So what we have here is what we have here is the angle BAC, and it's denoted by this angle x here. So let me so this is kind of our focus here, this x here. And what we're doing is we're finding a trigonometric ratio to solve for this angle, right? So so let's look at multiple choice 1. This is the inverse of cos of 5/13. So inverse cos of 5/13. So in this problem, they did, so this is inverse cos of 5/13, which means if we took cos and placed it to the other side, and this would equal x, right? So let me do x equals cos, the inverse of cos 5/13. So if I took cos and put it back to the left side here, I would get cos x equals 5/13, right? Equals 5/13. And we know our trigonometric ratios here. We know it's SOHCAHTOA, right? SOHCAHTOA. So we know sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So with this here, we have, this would have been adjacent over hypotenuse, right? Which here, in this case, is our answer, right? By verifying 1, this is the correct answer. Adjacent to x is 5 here. Remember, 12 is opposite here, adjacent here, over hypotenuse, which is 13. So this A here is correct, right? A here is a trigonometric ratio that shows this, denotes this angle, right? So A here means it's correct. Whatever cos -1, inverse cos of 5/13, that's correct. So question A is the correct answer. Let me just verify that B and C and D are wrong. So we have inverse of sine of 5/13 equals x. If I took sine and placed it to the other side, I would get 5/13 equals sine x. And as you can see, remember, sine x is opposite, or sorry, it's it's opposite over hypotenuse. Opposite here is 12/13, not 5/13. So this here is the wrong answer, because this here is wrong, because this is supposed to equal 12/13, right? The opposite of x here. We can also look at C. So so C states that inverse of tan equals 12/13 equals x. Again, if I move tangent to the other side, I'm going to get 12/13 equals tangent of x. And as you can see, tangent of x, again, is opposite over adjacent, right? Opposite is 12, adjacent is 5, which means this here is my wrong answer as well, right? I should have 12/5 as tangent of x. So this here is wrong. tan of x actually equals 12 over 5, right? Remember opposite over adjacent here, so that's wrong. And let me just double check D for you. So D here states that cos -1 equals 12 over 13. Cos -1 of 12 over 13 equals x. If I move cos to the other side, I would get 12 over 13 equals cos x. And as you can see, cos x here is adjacent over our hypotenuse, 5 over 13, and not 12 over 13 here. This would have been opposite. This is sine of x here, opposite over hypotenuse. So this here is wrong because cos x equals 5 over 13. So in this case, A is our correct answer here. So let me just box that, which means A here is our correct answer. Cos -1x, the inverse of cos equals 5 over 13, which means A here is our correct answer. So let's check the solution. Option A is correct, so they got that right. The right triangle is given by ABC, yeah, which is this angle here. They showed side lengths here. So cosine is defined by the length of the base, the adjacent, divided by the length of the hypotenuse. That's good. So they defined cosine, sine, and tangent. So that's good. Remember, cosine is adjacent over hypotenuse, sine is opposite, or the length of the perpendicular. Remember, this is the perpendicular over the length of the hypotenuse, and tangent is length as the opposite over the adjacent here. So for BAC, BC is the perpendicular, so it's 12. AB is the adjacent, which is 5, and AC is the hypotenuse here. So let me give you the letters here. So it's A, B, and C. Oh, sorry, I'm still in box mode. Here's A, this here is B, and this here is C, right? So remember, BC here is the opposite here. AB is the adjacent, and AC is the hypotenuse, which means, and they verified all of this stuff as well. So cos, which means A here is correct. Cos of BAC is 5 over 13, right? And that here is correct. And then they verified the sine, it actually equals 12 over 13, like so. Tangent, they did 12 over 5, like so. So therefore, all of these other solutions are false. So this here is the correct answer. So great solution and analysis. So the solution is correct.